This is the Algebra Chapter 9 test review. The questions on the review follow the questions on the test very closely. They are numbered out to the side so you know what to match them up with. This review may be used on your test. For questions 1 through 4, you are to find the sum or the difference. The first question is a difference because we have the subtraction sign. So when you're writing this out, the first one's going to stay the same. 4a cubed minus 2a plus 1. When we write the second one out, though, we're going to have to change all of the signs of what's in the parentheses. So the a cubed becomes a minus a cubed. The minus 2a becomes a plus 2a. And the plus 3 becomes a minus 3. We then put them together. 4a cubed minus a cubed will give you 3a cubed. Negative 2a plus 2a cancels out to nothing. And plus 3 minus 3 becomes a minus 2. And so this is your answer. The next question is an addition problem. The only thing that we need to be careful on this one of is that the numbers aren't in necessarily the correct order. We have, that says a negative 3n, but I'm thinking that's supposed to be probably a negative 3n squared. We're going to change that, so make sure you change it on your notes. So we'll say this is a negative 3n squared plus 7n. If I'm adding this whole next part, I don't need to change anything because of the addition sign, but I do need to make sure that everything's lined up. That 4n cubed, I'm going to put it over here because the first one didn't have a cube to match up with. Minus 2n squared goes underneath the minus 3n squared because they're both n squared. And the plus 12 is going to go all the way out here because there was no just a number in that first one. And there's nothing to match up with the 7n from the first one. So then we put them together. If there's nothing above it, it just stays the same. 4n cubed. This becomes a minus 5n squared plus 7n plus 12. And that is your answer. Questions 5 and 6 of your test will have a word problem type of a situation, and they're actually going to give you some information. These should match up pretty closely with the test. During the period 1985 to 2012, the projected enrollment B in thousands of students in public schools and the projected number R in thousands of students in private schools can be modeled by these two equations. B equals negative 18.53 t squared plus 978.8 t plus 48,140, and R is 80.8 t plus 8,049, where t is the number of years since 1985. 5 says to write an equation that models the difference in the projected enrollments for public schools and private schools as a function of the number of years since 1985. The key word in here is difference, meaning that we need to subtract the two equations. So let's start with negative 18.53 t squared plus 975.8 t plus 48,140. Then we're going to subtract this. So if I'm going to subtract the R, both of those need to go to negatives, and I need to make sure I line them up. So it's going to be a negative 80.8 t minus 8,049. There's nothing with the t squared, so it's going to remain the same. For the next part, when I subtract those, I'm going to get 895.0 t, or just 895 t. And that's positive, so make sure you put a plus between them. And then to subtract the next ones, you will get Let me double check my math on that one. And you do get 40,091, and that's positive. So this is the answer to question number 5. We subtracted the 2, and that's what we get. In 6, it says to find the difference in projected enrollments for public schools and private schools in 2005. So what we need to do is we need to know how many years there have been since 1985. 1995 would be 10 years, and 2005 would be 20 years. So we're going to substitute a 20 in for the t. So it's going to be negative 18.53 times 20 squared plus 895 times 20 plus 40,091. And when you put all of that into your calculator, you will get 50,579. And this says in thousands. So if you actually want to find the actual difference, it would actually be 50,579,000 students. On to 7 through 12, you're going to have to multiply polynomials. So in the first one, I've given you 5 different examples here. In the first one, you're just going to be multiplying what's out in front times each part of the parentheses. So to do the first part, negative 4 times negative 9 is 36. And then that's going to become c cubed, because you do c times c squared is c cubed. For the second part, negative 4 times 5 is a minus 20, and that's going to be c squared because you did c times c. And for the last part, negative 4 times 8 is a negative 32, and then there's a c as well. And so that is your answer. For one like the next part, you may choose to either do the FOIL method or set up a table. We're going to choose to do the FOIL method for this one. So it's first times first, so that's going to give us 5y squared. Outside times outside, y times negative 3 is a minus 3y. Inside times inside, 4 times 5 is positive 20y. And then last and last, 4 times negative 3 is a negative 12. I have to simplify this though. 5y squared plus 17y minus 12. And that's your answer. For one like the next one, you actually may choose to set up a table as opposed to doing a different kind of a method so that you don't lose track of things. So the way I would set up this table is I would have my s squared, my 6s, and my negative 5 down one side, and a 5s and a 2 across the top. Make sure you have negative signs where they're needed. So per square, s squared times 5s is going to give you 5s cubed. This one will be 2s squared, 30s squared, 12s, negative 25s, and negative 10. Now, these are alike, as are these. And so we're going to have to put them together before we get our final answer. Our final answer will be 5s cubed, because I didn't have to put that with anything. 30 plus 2 is a 32, so plus 32s squared. And then 12s and a negative 25s, that's going to give you a negative 13s, and then minus 10 does not go with anything. So that is your final answer. In our next example, you can either follow the pattern that we learned, or you can use a square or the FOIL method to help you work this one out. But this is a difference of squares. So what we have is w minus 5 and all of that squared, the pattern tells us that you're going to have the w and you're going to square it, and you're going to have the negative 5 and you're just going to square it, and you're going to get a plus 25. There will be something in the middle on this one. What you do is you multiply the negative 5 and the w, which is negative 5w, and then times 2 again, which gives you a minus 10w. But again, you could set this one up as w minus 5 times w minus 5 and use a different method of solving it. And for the last one, this one has a pattern as well, and it will be 16p squared minus 1. Because if you went ahead and you multiplied all this out, the middle parts would cancel out. And so you end up just squaring the first and the last, and it's always going to be a minus in this case. Always be a minus sign in the middle. On questions 13 and 14, this is a Punnett square problem. In our notes, also in an assignment that we did, there are questions on this Punnett square problem that are almost exactly like the question on your test. So you need to go back into your notes, find that example, and you can also use your notes from the chapter to help you on the test as well. In questions 15 and 16, you're going to have to solve the equation. So in these questions, they're actually going to have them already factored out, where all you have to do is set each part equal to 0. So we're going to say h minus 7 equals 0, and 2h plus 1 equals 0, and then solve for h. This one's going to be h equals a positive 7, and on this one you have to do a little bit more work. You're going to get 2h equals negative 1, and then when you divide by 2, you'll get h equals negative 1/2. So your two solutions are 7 and negative 1/2. In questions 17 through 19, you're going to be factoring out the greatest common monomial factor. So you're going to be looking for numbers and or variables that they have in common to pull out to the front. So for this first one, I look at my 12 and my 3, and I can see that I can pull a 3 out of both of those. The first one has an x squared and the second one has an x. I can only pull out one x, and I cannot pull out a y at all, because the first one does not have a y. So I can pull out a 3x. Well, 12 divided by 3 is 4, so you're left with a 4x. I took that 3 out of the second one, so it's kind of gone, and the x. Those are both out of that first part, so all I have left is a y. And that's my answer for the question 17 through 19. And then the second one, I have a 9 and an 18. I can pull a 9 out of both of those. And a z squared and a z cubed. I can pull out, I put my parenthesis too soon, but I can pull out a z squared. So in my first one, I've taken everything out, but that leaves me with a 1. Of the second part, I took 9 out of 18, so that leaves me with 2, because 18 divided by 9 is 2. And I took 2 of the z's out, so I'm left with 1z. So my answer is 9z squared times 1 minus 2z. I can use that same method to help me solve an equation. So what I need to do on this first part right here is I need to factor out a greatest common monomial. So I can factor out a 3 and an x, which leaves me with a 4x for the first part and a 1 for the second part. So I set each of those parts equal to 0. So 3x equals 0, and 4x plus 1 equals 0. The first one's just going to give me x equals 0. On the second one, I have to subtract the 1, and then divide by the 4. That's going to give me x equals a negative 1/4. So those are my two answers, 0 and negative 1/4. On the second one, I need to move the 18z to the left side before I can actually factor it and then solve it. So when I move the 18z, it's going to be a minus 18z, and all of that will equal 0. I can factor out a 9z. That leaves me with just a z, okay, because I took the 9 and one of the z's out, minus 2, because I took 9 of the 18, so I divide that, I get 2, and I took the z away. So now I can set both of those parts equal to 0. And the first one will give me z equals 0, and then z equals 2. And those are my two solutions. Questions 22 and 23 on your test will be a vertical motion model question. In this one, a juggler throws a ball from an initial height of 4 feet with an initial vertical velocity of 30 feet per second. The height h can be modeled by h equals negative 16t squared plus vt plus s. T represents the time in seconds the ball has been in the air, and v is the initial vertical velocity. S is the initial height. So for 23, or in our case on the test 22, we're going to start with writing the vertical motion model by plugging in the numbers that we know. So we're going to get h equals, and we're going to use this right here, substituting in things we know, negative 16t squared plus vt. V is the initial vertical velocity, and we were told that that was 30. So that's going to be plus 30t, and plus the initial height of s. The initial height is 4, so plus 4. And that will take care of the first question, just writing the equation. In the next one, it says, if the juggler misses the ball, after how many seconds does it hit the ground? So what we're trying to do is we're trying to solve for t, but we're wanting to know t when the h, height, is equal to 0. So I'm going to factor this and then solve for t. Now before I can factor this, I need to pull out a negative, because I don't want that negative, and I can also pull out a number. I'm going to pull out a negative 2 from each part of this equation before I actually factor it. So that's going to leave me with a positive 8t squared minus 15t minus 2. So I need to find factors of 8 and negative 2. So for 8, I can do 1 times 8 and 2 times 4. For negative 2, and I'm going to have to switch these around because my 8 has more than one factor, and they can be switched around. For negative 2, I can have a negative 2 and a 1, a 2 and a negative 1, or I can have a 1 and a negative 2, and a negative 1 and a positive 2. And all of those can go with 1 and 8. And then I'll do the same things for 2 and 4. Negative 2 and 1, 2 and negative 1, 1 and negative 2, negative 1 and 2. And each of those would go with a 2 and a 4. We're trying to see which one of those will give us a negative 15 in the middle. So what I do is I multiply the outsides and the insides. For the first one, if I multiply the outsides, I get a 1, and the insides I get a negative 15, or negative 16. 1 plus negative 16 is negative 15, so it's actually going to be the very, very first set that we set up. So that's going to be t minus 2 times 8t plus 1. And of course we've pulled a negative 2 out in front of all this. Now I want to set each one of those equals to 0. So t minus 2 equals 0, and 8t plus 1 equals 0. We need to find an answer that makes sense here, meaning that it needs to be positive because we're not dealing with negative time, we're only dealing with positive time. So I have t equals 2, which is positive, so that one would definitely make sense. On this one, I'm going to get 8t equals negative 1, so when I divide by 8, I still get a negative answer, so it's not going to be that one. So my answer is t equals 2, and so how many seconds does it hit the ground? 2 seconds. On to questions 24 through 26. You're going to be factoring the trinomial. We're going to set up a table to help us figure this one out. The first one is just an n squared, so all I have to do is find the factors of a negative 72. So that would be a negative 72 and a 1, a 72 and a negative 1. Neither one of those is going to give me a negative 14 in the middle. It could be a 2 and a 36, or I should say a negative 36 and 2, or a positive 36 and a negative 2. Again, neither one of those is going to give me the negative 14 I'm looking for. I could have a negative 24 and a positive 3, or a positive 24 and a negative 3. Again, neither one of those is going to give me the negative 14 in the middle that I'm looking for. My next options could be a negative 18 and a positive 4, or a positive 18 and a negative 4. And this is actually where I'm going to get my negative 14. Negative 18 plus 4 is a negative 14. So I'm going to have n minus 18 times n plus 4. And that is factored. For the next one, I have to find many different things here. I have a 6 and a 12, and I'm trying to get a negative 1 in the middle. So I have to list out factors for 6 and negative 12. So when I list out our factors of 6, I have 1 6, and we have 2 3. And so I'm going to try to give myself a little bit of space here because I'm probably going to list them over here. 2 and 3. This would be a positive 6. So for negative 12, and again, we're trying to get a negative 1 in the middle. So we might put some of these together as we're going along so we can maybe stop earlier. But I have a negative 12 and a 1. Okay, that's not going to give me a negative 1 in the middle. It could be a 12 and a negative 1. Still much too big numbers to give me a in the middle. But I also have to switch them around. 1 and negative 12. That one will get me closer, but definitely still not to 1 because I have a negative 12 and a positive 6. Or a negative 1 and a positive 12. And still that doesn't get me close enough. So it's not going to be any of these factors. But I can go ahead and I can try those with the 2 and the 3. A negative 12 and a 1. That's going to give me a 2 and a negative 36, so those are too big. A 12 and a negative 1 gives me a negative 2 and a positive 36, still too big. 1 and negative 12 is going to give me a negative 24 and a 3, so I'm still looking at numbers that are too large. Negative 1 and 12 is 24 and a negative 3, so those are still much too big. So 12s and 1s are out. Then I can move on to 2s and 6s for 12. So I can have a negative 2 and a 6, a 2 and a negative 6, a 6 and a negative 2, a negative 6 and a positive 2. So when I work those out, I do the outsides and the insides. That's going to give me a 6 and a negative 12. Too big. Or negative 6 and a positive 12, still too big. A negative 2 and a 36, much too big. A 2 and a negative 36. So none of those are going to work for 1 and 6. Let's try 2 and 3. Use the same numbers. Negative 2 and 6. 2 and negative 6. 6 and negative 2. Negative 6 and 2. These numbers seem a little bit more reasonable, so maybe we're on the right track. We still have another set of factors that we can try if these don't work. So 2 times 12 is 2 times 6 is 12. Minus 6, no. Negative 12 plus 6, no. Negative 4 plus 18, no. 4 and a negative 18, no. So we're still not getting our negative 1. So now let's try, and I'm going to erase because I don't have enough room here, but now let's try it doesn't want to erase. So now let's try, we'll just write it down here. Our 3's and our 4's. Okay, so I can have a -3, +4, 3, -4, 4, -3, and -4, +3. And I'm trying all those with a 1 and a 6. So that's going to give me a 4 and a -18, no. -4 and +18, no. -3 and a +24, no. A +3 and a -24, still no. So none of those worked. We're going to try the same factors with our 2 and our 3. So again, we have 2 and 3. We're going to try -3 and 4, 3 and -4, 4 and -3, -4 and +3. So our answer should be here somewhere. We have an 8 and a -9. 8 plus -9 is -1. So it looks like we have found our correct combination. So this one will be 2k minus 3 times 3k plus 4. And that will be our answer. In 28 through 30, you're going to be factoring the polynomial completely. So remember that when we factored a polynomial completely, we had to first factor out the greatest common monomial factor. So in this first one, I'm looking at a 9, a 30, and a 25. And unfortunately, there is no number that you can pull out of each one of those. However, with a t to the 4th, t cubed, and t squared, you can take out a t squared from each one. So that will leave you with 9t squared plus 30t plus 25. So I know that I'm going to be factoring out this t squared from the beginning. But now I need to look at factors of 9 and 25. And luckily, 9 and 25 do not have many factors. But I need to look at those to see what will give me a 30 on the inside. So let's start with factors of 9. Factors of 25. So let's start with 1 and 9. For 25, and these are all positive, and that's a very helpful thing for us because I don't have to look at any negative factors. I'm going to look at 1 and 25, 25 and 1, because you still have to switch them around, and then 5 and 5. Okay, that's all you have to do for that one because you can't switch 5s around. So, 25 and 9, not going to give me 30. 1, and that's going to be way too high. And then we have 5 and 45. 5 and 45, it's only going to give me 40, but it's fairly close. There are other factors of 9, though. I need to try 3's out. So one of these should give me my answer. We have 75 and 3. No, too big. 3 and 75 is too big. But here I have 15 and 15. So it's going to be t squared, because that was what I pulled out from the beginning, 3x plus 5, and that's going to be the same, so it's actually going to be 3x plus 5 squared. And this was actually one that we could have looked back at one of our patterns. The ends are perfect squares, and 3 and 5 is 15, and then 15 times 2 is 30, which gives you the middle one. So we could have used our pattern to figure this one out. It wasn't that difficult in the end because there were few factors of 9 and 25. But that is your answer. And then for a question like the next one, I can factor out an x cubed. So I have an x cubed, and that leaves me with an x cubed minus 1. I believe there's actually a typo in this. I believe that's supposed to be x to the 5th. So we're going to change this to x to the 5th. which then in turn changes that 3. I won't erase, but that changes that 3 to a 2. So it's x squared minus 1 inside. But I can still factor out an x cubed from both parts. So that leaves me with x cubed, and this is going to be, it's one of our patterns that we learned, x plus 1, x minus 1. And again, if you are not comfortable with the pattern, you can always work the problem out by listing the factors, and this one wouldn't have taken very long to list out the factors for. And for this next part, this one was actually this one's fairly easy because we see that they share that a minus 3. And so when they share that a minus 3, what we do is we take that a minus 3, and it's like factoring the a minus 3 out of the entire thing, which leaves you with a 5a minus 7, which is the answer. And that's all you have to do to factor that one out. In questions 31 through 32, you have to solve the equation, but again, you are going to have to factor out, factor the whole thing completely before you can actually solve the equation. So, in this first one at least. So this first one, I need to pull out a 2 and an x squared from each part. Okay, taking the 2 out of the first one leaves me with just a 1, and then taking 2 of the x's out leaves me with x squared. 16 divided by 2 is 8, and that leaves you with 1x because you took 2 of the 3 out. And in the end, it's a 15, and you took both x's out. Before I can set everything equal to 0, and this one's actually going to have more than one different answer, or more than 2 answers, we need to factor out the polynomial here. So that's going to leave us with a 2x squared still. We're going to have x plus something in both of them because everything's positive, and that's very helpful to us. So when I list out my factors of 15, I'm trying to get an 8 in the middle. I have 1 and 15, and I don't have to change the order. That'll give me 15. And 3 and a 5. Well, 3 and 5 will give me 8. So it's x plus 3, x plus 5. And then when I set all of these parts equal to 0, I have 2x squared equals 0, x plus 3 equals 0, and x plus 5 equals 0. Well, 2x squared, it's going to equal 0. If I divide both sides by 2, that still gives me x squared equals 0, and then x has to equal 0 for that one. This one's going to be x equals a negative 3, and this one will give me x equals a negative 5. And so those are my 3 answers. And for this last one, it's actually set up to where you just have to set, you will have to multiply. We're going to multiply and then move the 72 over. So we're going to do n times n, and n times the negative 14, and then I'm going to move that 72 over to the left side. So that's going to leave me with n squared minus 14n, and then when I move the 72 to the left side, it becomes a minus 72. And all of that will equal 0. I need to figure out what factors of 72, negative 72, will equal negative 14. We're looking for positives and negatives here. Negative 72 and a positive 1, a positive 72 and a negative 1, those numbers are going to be much too large for what we're trying to do here. So I move on to dividing by 2, which gives me a negative 36 and a positive 2, or 36 and a negative 2. Again, the numbers are too large, although they are getting a little bit closer. And then let's try to see if 72 goes into, or 3 goes into 72. It does. That leaves me with a 24, negative 24, and a 3, or a 24 and a negative 3. Also too large, but again, still getting closer. If you do 72 divided by 4, that's 4 and 18, so that's probably going to give us our answer. We have a negative 18 and a 4, an 18 and a negative 4. We're looking for the negative 14, that one's going to give it to us. So our answer, I'm going to move up here where I have more room, when I factor it, is n minus 18, n plus 4. And all of that equals 0. So I set each part equal to 0. And that gives me n equals 18 as one of my answers, and n equals a negative 4 for the other answer. And for the final question of our review, a small vegetable garden has an area of 50 square feet. Its length is 5 feet more than its width. Find the dimensions of the garden. So I'm going to take this, and area is length times width. So we're going to take the x times the x plus 5, and we're going to set that equal to 50 because that's what it tells us the area is. I'm going to multiply x squared plus 5x, and I'm going to take that 50 and move it over to the left side by subtracting it, setting it all equal to 0. I need to factor and then set equal to 0 and solve and pick the answer that you're probably going to get a positive and a negative. So you're going to pick the answer that's positive. So I'm looking for factors of negative 50 that add up to a positive 5. Well, negative 50 and 1, no, that's going to be much too high. That's going to be a negative 45. And a 50 and a negative 1 will give you a positive 49. So we move on to 2. So it'd be a negative 25 and 2, or 25 and negative 2. That one will give you a negative 23, and the last one will give you a positive 23, so we're still too high. 3 is not a factor of 15. 4 is not a factor of 50. 4 is not a factor of 50. 5 is, though. We have negative 10 and 5, or 10 and negative 5. We're looking for the positive 5. This one will give us a positive 5. So we have x plus 10 times x minus 5. So setting each one of those equal to 0. The first one's going to give you a negative 10, not the answer we're looking for because we need positive dimensions. The second one gives you an answer of 5. It says find the dimensions of the garden. So the garden is going to be 5 by 10. So 5 feet by 10 feet. And that concludes the chapter review for Chapter 9. This is a long test. It may take more than one day to complete.